Dear students, in this video I am going to discuss about the image in mirror, concave mirror and convex mirror. You know, concave mirror is known as converging mirror and convex mirror is known as diverging mirror. You should draw the ray diagram according to my instruction. Let's start.
Line representing the principal axis. Using a ruler, mark 3 points where C is at 0 centimeter, F is at 3 centimeter and P is at 6 centimeter. You can take any convenient distance. F should be exactly in the middle such that CF equal to FP. C is the center of curvature, F is the focus and P is the pole of the mirror. Now use your compass to draw an arc for the concave mirror. The compass point should be placed at C, the center of curvature, and the radius of the arc will be CP, which is equal to 6 centimeters in this case. Mark the backside of the mirror with these dashes. Rule 1. A ray of light which is parallel to the principal axis after reflection passes through the focus. Rule 2. A ray of light passing through the center of curvature is reflected back along the same. Rule 3. A ray of light passing through the focus after reflection becomes parallel to the principal axis. Can you see that rule 3 is exactly opposite of rule 1? It's due to reversibility of light. Rule 4. A ray of light which is incident at the pole of a concave mirror is reflected back, making the same angle with the principal axis. It looks like a plane mirror type of diagram since the principal axis is like the normal here and the angle of incidence is equal to the angle of reflection. Let's place the 4 rules that we have learned for concave mirrors on our concept board. Avoid using the 4th rule unless really necessary, because it's hard to measure angles accurately with your protractor. So it can lead to inaccuracies in the diagram. So basically you need to use 2 out of the first 3 rules for concave mirrors.
Dear students, now we will start to draw the ray diagram of concave mirror. In concave mirror, we will study 6 cases that depends on object position. Now I am showing you these 6 cases overview. Case number 1, object is at infinity. It means the object is in far away from concave mirror, like sun, moon, etc. Case number 2, object is beyond C. That means near the center of curvature. In case number 3, the object will be at C. In case number 4, the object will be between center of curvature and focus. In case number 5, object will be F, and in case number 6, object will be between F and P. This is overview of our 6 cases. Now I'll discuss in brief about the ray diagram of first case. To draw the ray diagram, at first we draw principal axis where select center of curvature, focus and pole. By this time, after drawing the diagram, we will find object, image, size of image and nature of image. Remember that object will always be in front of the shining surface of concave mirror. Like mirror, we always stand in front of mirror, not the behind of mirror. So let's start case number 1. The object is in the infinity. A light ray will fall on the mirror parallel to the principal axis. After reflection, it will reflect through focus. We know we need 2 rays to complete this diagram, so another ray will also fall on the mirror. It may come to the mirror by center of the curvature or from another part. We need minimum 2 rays that I told earlier. Now another parallel ray that is also parallel to the principal axis fall on the mirror from object and also reflect through the focus. Then two rays bisect at the same point F, that means focus, that means in focus, so our image will be at F. This image size will be highly diminished and its nature is real and inverted. So our image is highly diminished, its nature is real and inverted. Okay, let's move on. Case number 2. Now object is beyond C. Similarly, one light ray parallel fall on the mirror from object. After reflection, it will pass through the focus, and the light also passing from focus and reflected parallelly to the principal axis. By this time, both rays bisects one another below the principal axis, and the image is between C and F. Well, size of image is diminished because object is larger than the image, and the nature of object is real and inverted. As it is in front of mirror, so it is real image. Definitely it is real image. Now move on, case number 3. Now object will be at C, that means center of curvature. Now one light ray fall on the mirror from object which is parallel to the principal axis. After reflection, it will pass through focus. Another ray pass from the focus and reflects at the parallel to the principal focus. When both of the reflected ray bisect each other under the C, that means under the center of curvature, as it is below the principal axis, so the image is inverted and size will be the equal of object. So image is as at C. Size of image is same like object and nature is real and inverted. Now move on to the case number 4. The object is between center of curvature and focus. One light will fall on mirror in parallel to the principal axis. After reflection, it reflects through focus. Another ray will pass through focus and it will reflect parallel to the principal axis. Both rays bisect each other at beyond C. So image will be beyond C. Size of image is larger than the object that is enlarged. Nature of size is real and inverted. So here the size of image is real and inverted. Let's move on the case number 5, where object is in the focus. From object, one light ray fall on the mirror parallelly and reflects from the focus and passed away. Another light ray fall obliquely on the mirror and it reflects from center of curvature, but both of the light ray will not bisect each other in near point. They will maybe bisect each other at the infinity. So our image will be at the infinity. As they will meet infinity, the size of image will be highly enlarged, and the nature of image is in front of the mirror, so it will be real and inverted image. Last case, case number 6. When the object will be between F and P, that means focus and pole. Now from object, one light ray fall on the mirror parallelly. After reflection, it will back through focus. Another light ray fall on mirror obliquely and passes through the center of curvature. Both of the reflected ray don't bisect anywhere. If I extended both of the ray behind the mirror, then they will meet together behind the mirror. Where I find the image, by this time our image is behind the mirror. size of image is enlarged because image is larger than the object. Now nature. What is the nature of the image? As the image is formed behind the mirror, so it is virtual and erect. Now move on to the reflection by convex mirror. Here we have to follow only two cases of object position. In first case, the object will be in the infinity, and the second case, object will be in front of the mirror. So move on to the case number 1 in convex mirror. Now on parallel light ray fall on the mirror, it will pass through the focus. But focus is in the opposite side of object, so we draw an imaginary dotted line through focus and extend it to the back. It means it reflects to the back. We need to light ray draw another one. Another light ray will fall on the mirror parallelly under the principal axis. After reflection, it will meet at focus. Now again I extend it to the back. As the both rays bisect at F and imaginary, so the image will be behind the mirror and highly diminished. Its size will be point size, that's mean very small, and nature is virtual and erect. At last case of convex mirror, the object is in front of the mirror. On light ray fall parallel to the principal axis and it is passed through focus. If I extend it, it will go like this. Another light ray passes obliquely and it will pass through the center of curvature. Again it will be extended behind. These two rays diverged back to the mirror. They meet together at behind the mirror. So image size is diminished because the size of image is smaller than the object, and nature of object is virtual and erect. So that's all about the ray diagram of concave and convex mirror. I hope you understand. Thanks a lot for being with us.